Uh, hey there, welcome all to my talk. My name is Rafik Krikorian. I work on the platform team over at Twitter. Specifically, I'm the engineer who built the original geotagging API at Twitter, and I've been working really closely with our new geo team to start building out the rest of our geo infrastructure for the rest of the kind of things that we want to be doing around status updates. So I'm structured this talk in this way, and it's not as technically heavy as some of you may want necessarily. Like I figure I'll do a general overview about location in general and adding location to applications. I'm going to frame it all in the context of what we've done at Twitter and some of the applications that are built around Twitter or use Twitter, such as like Foursquare or Gowalla and stuff like that. And at the end, I'll open it up for questions, and I'm happy to talk as deeply as I can about actually what we do at Twitter. I probably have the code somewhere on my laptop, so we can probably actually talk about our actual detailed implementation, our representation formats, how we manage all this data through the system, if that's what people also want. So for us, location really means a bunch of things, but it really comes down to providing context and providing relevancy to Twitter and to the statuses that flow through our system. Like right now, we're in a very constrained environment where everything that we do is at 140 characters. That's all you have to play with when you're actually talking on the Twitter system itself. And we wanted to add metadata to that in some way. We wanted to allow people to give more contextual information to those 140 characters. And what we found is that people really actually do want to talk about places. Like that comes up a lot through the system. So like this is a tweet from Ev, our CEO, where talking about our tea time that happens every Friday evening, and how we should be drinking more beer there. But if you actually go click on the link, it's an actual location from where that tweet came from, and it provides you as a person who might be following Ev some obviously relevant information, like where is he when he's making that tweet, what is he talking about when he's making that tweet, or where is he talking about when he's making that tweet. So we're moving the platform from more than just time, but also place. Like we're adding those, the first 3 dimensions to it. And there are other cases where you want to sort of do this. This is a picture I took the day we moved into our office for the first time, our new office. And we all got these nice pillows, but it's also like Flickr has this way for you to see exactly where, optionally where that picture was taken from. And these are the kind of use cases that we sort of want to be able to tackle, like being able to actually annotate exactly where information is coming from or what information you might be referring to in the system. And this is a paradigm that's sort of happening on a lot of different applications, not just Twitter. It's like a lot of social networking platforms or a lot of information-based platforms just want to have this other piece of contextual information that may not be right in the text of what people are trying to talk about, but people, like if people just want to have that natural extension of being able to talk about the stuff that's around them. So the other example I'm going to use a lot, and this is a slightly out-of-date screenshot, is the Foursquare application and how they talk about where people are by allowing them to explicitly check into different locations. So if you haven't used Foursquare before, what it does is you bring up your application, you hit the check-in button, and it'll list you all the places that are nearby where you are right now. And then you say, I'm going to check into this one. For example, I check into my gym every morning. And it blasts out to your social network where you are and maybe a small little status message that goes with it. And it provides such a great thing for your Friday nights out where you want to say, I'm at the bar right now and all my friends should come find me. It allows that way for you to add that context so people can search. And it just provides a relevancy to the conversation. But the one thing that I'm not going to talk a lot about today, but I just wanted to bring it up, was that sometimes the actual physical location doesn't matter. This is one of my favorite newfound apps, Yakutine. And what they do is they create chat rooms around either the Wi-Fi access point you're at or the cellular IDs that you're nearby if you're on a mobile phone. So it allows you to have conversations with people who are nearby to you. So it adds that, again, another layer of context. So just being able to find that level of people that you want to network with. But so, getting right down to it. What is a place? So for us in the beginning, a place was a set of coordinates. So those are the latitude and longitude of the Mandalay Bay. Actually, probably right above the hotel room I'm staying at, so if you want to stalk me in some way. But this doesn't mean very much to people. It's just a pair of decimals. It gets really complicated when we want to start talking about precision. But again, if you saw those numbers on a tweet or if you saw those numbers coming through a social network, it's not going to make much sense to you. It's not going to make much sense to your users. It's really convenient for computers because you're just going to store a latitude and longitude to decimals. But again, people don't make much sense to it. And my comment there about it getting complicated when you want to account for precision, it's actually something that we tackled at Twitter, in that the number of decimal points you're going to put after the number of zeros you put after a decimal point in your latitude and longitude actually means something. You can't just simply round off, or you can't simply just keep 16 digits after a decimal point for every single time. Sometimes people just don't know their location to that granularity, and you want to sort of capture that in the system somehow. But again, so these coordinates don't mean anything unless you actually put a map on the screen for people to consume it. It's not really simple. So a place can also be a polygon. So for example, this came off our system when I tweeted this morning. I tweeted from somewhere around the strip. So that red zone is the strip according to a bunch of different databases. So that could be a place also. It has a few more features than a point itself, because you don't know exactly where I am, so I can sort of add context to my tweet, but not say precisely where I am if I'm concerned about some privacy implications. But I mean, if you thought one pair of decimals were hard to store and to process and display to users, that polygon is made of, I think, 14 different pairs of decimals. So you can store that again really easily, but users are just not going to get it unless you put it on a map. So what's more interesting to us and where we're moving towards, and where I think a lot of other people are moving towards also, is giving a place a name. So a name obviously can be a bunch of different things. It could be an exact address. It could be an intersection of two streets. It could be some canonical name that people sort of know places as, so either your neighborhood or some other nickname for a place. It could be a business or a point of interest. For machines, it could actually be an ID, and those are the two different IDs. The WoW ID is Yahoo's Where on Earth ID for Las Vegas, and the one on the left is Twitter's ID for Las Vegas. So it could be some kind of ID representation that then links to a richer data set somewhere. But these are probably, or what we think are, the ways that people really want to talk about places themselves, like not talk about coordinates. Coordinates are interesting when you want to put them on a map or when you want to process. Coordinates are really useful when you're building a search engine and you want to restrict to a sort of geographical boundary. But names are what people want to see. But of course, it opens a whole bag of worms when it comes to internationalization. And this is something that we're tackling with, and I'm sure a bunch of other people are also tackling with, of how do you actually name something so it makes sense to the person that's looking at it. And I'll talk about this more in a bit. So it's also useful to understand like what users kind of expect when they want to use location information. So like I said before, like sharing coordinates is it's something that some people might want to do. There's very specific use cases for it. Like we call this geotagging internally, and it's specifically good for when people want to tag where a photo was taken from, or maybe when they're talking about very small venues. So like a restaurant or a bar or a movie theater might work for coordinates. But again, people just don't understand it unless you put it on a map for them to take a look at. And of course, there are huge privacy implications to broadcasting exactly where you are at any given time. You know, for Twitter, we're all about what's happening right now. But if I want to talk about where my party is going on, and I don't want people who I don't know showing up, tagging my house might be a bad idea, or even exposing my house in general, or tagging someone else's house might be not the best thing to be doing. So that's where we went with sharing polygons, for example. So this is a shot of my Twitter stream on the left. And you can see, like, for example, on the coffee and laptop presentation time tweet, on the byline we have from the strip. It gives contextual information. It doesn't expose exactly where I am. If you click on the strip, we bring up a map. They'll show you a polygon of where the strip could be, so you can see it. Google provides us the maps, and it works really well because they usually come up around like city names, so you get an idea of where it is. We try to zoom it out to the appropriate level so you can, again, see the right context. But again, it's not, the name is useful, but the polygon gives more context. Not useful unless you're on a map specifically. So that's where we've gone with exactly these names. So like you can just read off on a bunch of my tweets, like from the Strip or from Mosswood, Oakland, or from downtown Oakland. This sort of illustrates the problem that names have when you go with internationalization. Like there's this inverse relationship also between granularity and the connection it makes to the user. So for example, the Strip might not mean very much to people who are reading my tweets in Japan. It might not mean very much when you're reading my tweets from Rome. But it also illustrates the problem you have when things are named differently depending on where you're looking at them from. So for example, like we're in the process of releasing more international data for our geo efforts. And it's a common question of like, how should we actually refer to Rome? Should Rome be named Rome? Should Rome be named Roma? Does it matter on who is looking at the tweet or where they're coming from on the tweet? So these are questions that we're currently working through, but it's also questions that everyone needs to be thinking about when trying to expose these kind of location information. And of course, like when you start diving deep into it, like I said before, the Strip doesn't mean very much to people who are not in Vegas or possibly not even in the US. And it's a question of how much granularity do you provide when you actually display the name so it can make sense to a user. Like downtown Oakland, I think is a good level for people who might be in California to understand. Does it work well for people who are in New York or people who are in Massachusetts to get what downtown Oakland really means? Totally doesn't work if you're outside the US unless you actually click on it. So it's a balancing act to try and figure out what's the appropriate level for everyone's users. But it's worthwhile talking for a few minutes of where location actually comes from. Like how can your machine or how can your clients actually get this data? So there are three main ways that computers in general can get access to this information. We use all three of them in some way, and I'll talk through them a bit. So there's triangulation, which comes down to three different ways, and one at a time. One is cellular triangulation. So what that means is that your mobile device, for example, listens to a bunch of cell towers, figures out what the signal strength is to all those cell towers, looks in a database of where those cell towers are, and then triangulates your position. So given the signal strength from all those places, figures out approximately where you could be if you're hearing those signal strength. It works really well. It works really well, obviously, only when places that have cell phone coverage. But if you don't have cell phone coverage, you're probably not using a social networking site on your phone in the first place. It requires a cell modem, obviously. It requires some software. It requires some lookups against the network, whether the lookups go to the cell phone provider's network or whether it goes to somewhere on the internet that has a database like CellDB or something, which has the locations of all the cell towers or a lot of cell towers to do the computation. Is up. But it gives you within 200 meters, sometimes 1 kilometer accuracy where you are, which, depending on the type of location you're trying to share, might be fine. If you're talking about a neighborhood, that's great. If you're trying to do a geotagging of where you took an exact photo, not so good. So another way to do triangulation is to look at Wi-Fi signals. So this gives you about sub 20 meter accuracy. It works indoors, it works in urban areas great, where everyone has an access point. There are databases out there. Skyhook Wireless maintains one. Google has another one, which has the locations of access points in the world. So if you can you listen for the MAC ID of the access point, the signal strength to it, and again, look up on a database, you'll find out roughly where you are to within about 20 meter accuracy. And it's really fast to be able to do this. In fact, this is the trick that an iPhone pulls when it's trying to get a location lock, because it usually does this first before it goes into GPS. So then the last one is GPS. That gives you about 1 meter accuracy, and it's awesome when you can get it. It's not going to work well indoors. There are a bunch of companies trying to solve the indoor problem. It has really big problems when you're in like urban valleys of high skyscrapers because you need to see the sky. And in those situations, you get what's called multipath, where the GPS signals just start bouncing like crazy in the urban environments. And the worst part about it is that it just takes minutes in order to get a really good lock. Like if any of you wear either a GPS device for when you're exercising, running, or biking, it takes a while for it to actually get a good lock to actually start recording your run or your bike ride. And that's just not going to be acceptable to a bunch of users when they're actually trying to do it. So again, like most mobile devices use a combination of the three, but they probably do it in the order of using cell tower and Wi-Fi first, because that's really simple and really easy to do, and then lock it down on GPS to get really close. And the E911 spec in the US sort of does recommendations for all this to be able to locate every single cell phone. So another technique, and Twitter also uses this, is association, where we try to map the IP address that our clients are coming from to locations in the world. So we do this in two different places. One, we do this on your initial page load. If you have location turned on, we'll do this on the initial page load just to push something out to you very quickly. We also do this when we're looking at aggregate data throughout the world. So we just try to figure out what people are generally talking about in Indonesia, or what people are generally talking about in Brazil, or people generally talking about in Europe. We'll use some IP-based tricks to do it because we don't actually care exactly where they're coming from. We only care roughly where they're coming from. You can get this data really easy. MaxMind is the provider that we use, but there are a bunch of other providers also out there. But the thing to know is that it's really noisy. Like MaxMind has only about 83% confidence that they'll give you information to 40 kilometers. So that's a city, maybe bigger than some cities. It's very error prone. It gets really wonky when you're on a cellular modem, or if you're in the air, for example, like if you're on a Virgin America flight and you use Wi-Fi in the air, it totally guesses that you're in LA, which is very entertaining, no matter where you might be flying. And if you use a cellular modem, then because people like AT&T or Verizon can jiggle their IP addresses around, it might get recorded at different places at different times, depending how quickly the database is refreshed with MaxMind. And for example, like this is a free IP location search I did this morning against the IP address in my hotel room. And that puts me at somewhere in Alabama. So it's clearly not an exact science, but it's something that you can do server side. Like everything else, the triangulation has to be done on the end client. It has to be done either in a browser, or it has to be done on a cell phone. This you can do on the server side just looking at IP addresses. And it might be enough if you can message to your user what's going on when it's seriously wrong, so they don't get confused when they're doing it. And the last trick, of course, is extraction. Like actually look at the text that's coming through the system and try to pick out what's going on. So there are some easy cases, right? If someone's talking about the United States, that can be trivially matched. Someone's talking about Massachusetts, someone's talking about Boston, someone's talking about San Francisco. Those can be pulled out and geocoded, and you can figure out where to go. There are a bunch of different services where you can just either run text through or run terms through to figure out what location comes from. Those are a few. Google, Yahoo, Geocoder US is one. One interesting thing that we've started doing, and other people have started doing also, is actually starting to pull structured URLs out of the text and crawling them to figure out where they might say they're coming from. Now, this becomes really useful in the case of like Foursquare check-ins or GoWalla check-ins, or where people actually put a place URL inside the text themselves. You can just crawl that and look at what they're actually talking about. So, for example, for all these Foursquare check-ins, like this Lori W person is talking about a Starbucks in Palmer Square. And you can find that by looking at that Foursquare page, and they have a map. You can scrape that map and figure out where that's coming from. So you can start extracting all these terms and try to figure out what people are talking about. It's definitely noisy. It's a natural language problem in some cases. It's definitely hard. If you're going to go down this route, you have to take into account that it's not going to work sometimes, but it'll work some other times. But it's also something that you can't be doing it for a user unless they're willing to type in some terms for you. So, for example, you can imagine a client on your cell phone where I'm trying to post either a geotag tweet or make some kind of location-based comment somewhere. My phone can go through the triangulation process. The server I'm talking to can go through the association process to try to come up. But doing extraction is not something as an option, right? Like I'll have to type something, the user has to type something in, hit the server to try to figure out what's going on. This is more useful on post-processing all the data and then trying to add location back into information that didn't have it in the first place. So getting the location is actually pretty straightforward these days. It's actually surprising how well it works. We do this at Twitter right now for the browsers I've listed below. There's a geolocation API specification for JavaScript. You just simply call navigator geolocation get current position, and it provides you a position object which has coordinates attached to it, provides you an accuracy level, like how many meters do you think it could possibly be off, and a bunch of other stuff. It provides elevation in some cases. Not necessarily would trust that, but it provides a lot of information that you could use in HTML or in JavaScript on the browser when trying to do this. Now, of course, there are also native ways to do it. Like the iPhone has the core location. iPhone OS has the core location APIs. Microsoft has their location APIs. Java for J2ME devices, those that still use it, have also the ability to access the location on the cell phone or the mobile device itself. So there are different native ways to do it. What we're doing at Twitter, since we don't make native applications, we make web applications, is to actually just hit the JavaScript version and get the data from there. And we find it to be pretty accurate. We log all the accuracy levels that come back through the system, and the radiuses that the browsers provide is actually surprisingly small given for what I thought they would be. Like on the order of less than 30 meters is what we're recording on average. One interesting other way to get location that I want to touch upon is looking at brokered location. So Yahoo has a great service called FireEagle. And what FireEagle does is allows you to connect a whole bunch of your location-based social networking or services to FireEagle, and they will publish the location they think you're at to FireEagle. FireEagle then attempts to rectify all that data and provide it back out to other people who might be interested. So for example, these are the apps that I have currently connected to my FireEagle. So Doppler is an application where you can log where you're going, what trips you're taking. Tweet-a-Lock is an app one of the Twitter developers in our ecosystem built, which looks at geotagged tweets and extracts those coordinates and sends them to FireEagle. Fire Check-in looks at my Foursquare stream and pulls out places that I've checked into and sends it to FireEagle. And what FireEagle does is takes all those location streams that are coming from all those different places and sort of comes up with a general notion of where the person is. And I can set privacy permissions to it. So if Tweet-a-Lock provides an exact coordinate, FireEagle will then sort of fuzz that out to either a neighborhood or a city, depending on what I asked it to do. And the great thing about this is that you can use this on server-based applications. Like if someone provides you FireEagle credentials, you can ask FireEagle, where do you think this user is? So having built no location infrastructure yourself, if your users are using something else that's talking to FireEagle, FireEagle will provide that data to you. So you can ask, like I can make an API hit against FireEagle today with my credentials, and it's going to say Las Vegas, which is great. Like I've never actually told FireEagle anything. I've just sort of passively done things in the rest of the ecosystem, and FireEagle has sort of coalesced that for me. So working with users. There are a bunch of UI choices around what users want to do. So like whether you want to implicitly or explicitly tag information to stuff that's flowing through your system is definitely a question you should be asking. We at Twitter have opted for the very explicit method. So we won't do any location-based stuff unless you have, one, opted into our service to do it, two, told us exactly where you are and chosen a location from a list. We'll make a best guess for you if you want, but you choose the location from a list and then we'll attach that location to you. And we just want our users to feel like they're in control, like they're exposing a lot of information whether they know it or not, and we just want them to be in the driver's seat for this type of data. So the workflow that we sort of use, and it applies generally to everyone, is that you guys sort of plan for things not being synchronous. So location is going to come in probably after the page load. Like you might get some from the server if they're doing some IP mapping, but then JavaScript is going to kick in, or all these other ways of getting your location is going to kick in after the page load. So we have this small little like getting your location throbber that comes on your screen. And people can tweet without the location. If they're willing to wait, then it might pop up and show something. You can then click on it and get a drop down to be able to refine it or choose exactly what you want to do around it. We have the infrastructure, and if others do, they should think about too, to actually try to learn from our users' actions. And what I mean by that is actually gather statistics of what our users are doing with that location information. Like we might be wrong, right? We might be providing a wrong set of data to our users, and they might be trying to implicitly correct it by like, no, 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 I'm not in the Strip, I'm somewhere else, or I'm not in San Francisco, I'm in a different city. And we might be returning the ordering incorrectly, we might just have bad data flowing through our system. So we log everything of what our users are served doing when it comes to location anonymously, except for what's actually attached to the tweet itself, so that we can try to understand and refine our data sets when it comes down to location itself. Lying is definitely a feature in location-based social networking, I think. And it's not just because you want to falsify. It's not because like you want to geotag that you are in your hotel when you're having an affair with your mistress or something like that. It's like you might want to be actually talking about a place that you're not actually at. Or you might be referring to a place that you were at a while ago and you're not there currently. For us, at Twitter, we're not building a verified location service. Like, we are not guaranteeing by any means that the person is where they said they were in the tweet itself. We're just providing a way to add an extra level of context. And it's something that it's something that designers need to think about when they're actually building these systems of whether or not you're trying to build a verified location service. Like Fire Eagle, they might be trying to build one, so they have a very different use case. We're not, and we just want to make sure that our users understand that, and they can sort of do whatever they want. If they talk to our APIs directly, they can give us a latitude and longitude of wherever on the planet they want to attach a tweet to. They can hit our reverse geocoder and get place IDs for anywhere in the world and attach a tweet to that. Like I did this when we were testing our geotagging API, and I want to talk about the Top Gun facility, and you sort of just attach the tweet to San Diego. There's no reason. I'm sitting in San Francisco. Privacy, this is the one that I keep on coming back to throughout it, so I figured it deserves a slide at some point. Like this is our section of our settings page where people can actually turn on location on their Twitter account. So by default, location is turned off. No matter what anyone does, send it through the API or try to do it from the website, we will not attach a location to your tweet unless this checkbox is turned on. And we don't even provide an API to actually access this checkbox. Like if you're coming from a mobile client, the mobile client has to send you to a twitter.com webpage that has this checkbox on it. Like we don't trust, it's not that we don't trust our clients, but trust our API clients, but we don't want any way for something to accidentally turn this on unless a user has actually clicked on that checkbox. And it's something to really think about when building location-based services because of the such privacy implications of attaching a location to your tweet. We also provide a way to do a mass deletion of all the location information on your account. Of course, we allow you to as well delete your account and delete all your tweets. But what I'm saying for this is that if you have a stream of, say, 3,200 tweets in your timeline, with one click of a button, in about 30 minutes, we'll have scrubbed location from all those tweets. So if for some reason you've gotten freaked out or you didn't realize exactly what's going on, we wanted to provide the one-button way for you just to delete everything. And not touch the actual text itself that you might be talking about. We don't provide an individual case-by-case basis of deleting location from tweets. We debated about that a lot, but it's something we just never actually settled on to actually do. We felt that this was sort of the better way. Like for us, tweets are immutable, right? They're not supposed to change. This is the one special case where we allow a tweet to change. Oh, and of course, the big question here is, can someone else tag your house? And this is something that we're dealing with a lot. We get a lot of questions from API developers. What I mean by this is, say I'm a user who has location turned off, so I can never geotag my tweets. I'm afraid I don't want to expose the location of my home. I don't want people to know where I spend most of my time. But then my friend or my boss is coming with me and then geotags my house for me. And if you're watching his stream, can you then figure out where my location is? So we're definitely on the let jerks be jerks attitude when it comes to this. We allow that to happen. It's a really slippery slope to do it the other way. Like you could easily conceive of me setting up a boundary around my house such that no one can tag anything around my house. But then the whole world is just going to be blanketed with these type of boundaries, and therefore geotagging becomes completely useless. Like at some point, we feel that you just need to trust the people that you're physically hanging out with to sort of respect your privacy and respect the things that you want to do. Like if you've gone that step from the online world to the physical world, you probably have an implicit level of trust, and you can sort of deal with it then and there in that case. So that's the general overview, and I just want to talk in specific about exactly what Twitter is up to. And then after this, I'm happy to take any questions on like the exact specifics of what we do or how we expose this to other users. So our original attempts at geotagging or sort of geolocating your tweets actually dates from a while even before I started. Like inside your settings page, we have a place that you can type in where you're from. So for mine, it says San Francisco, California. For other people, it says my mom's basement. So it's a free-form piece of text that really means nothing. It's just sort of an entertaining way to sort of add some kind of location to your stream. And the people also have been trying to put location into the 140 characters itself. Like that's what you saw in Ev's tweet that I showed in the beginning. And that's fine. It takes away from 140 characters, though. And it doesn't also provide us as Twitter a good way to sort of normalize location. So we can search across it, or so we can expose like aggregate information back to the user. So we just wanted to have a really good framework to allow people on a tweet-by-tweet basis to specify where this tweet is coming from. So well, this is, for example, an API call where you can see in my user object, you can see the location field I set as San Francisco, California, or I'm being able to set it, in this case, as San Francisco, California. So our geotagging API allows it on a tweet-by-tweet basis. So this is version 1. We launched this, I think, around November of last year. And it allows you on a status update call to actually attach a latitude and a longitude parameter, and we'll then store that information. And then we expose it using GeoRSS or GeoJSON on the way out. And those are two well-respected and used standards for either XML encoding or JSON encoding a point. They also have support for polygons and other issues. And we do it across all our APIs. So the REST API, which is what most people use to either update status or to look at timelines, has the location information. The search API, you can search, do a point radius search and find all the tweets that have been annotated in that radius. Our streaming API will stream out location data as well. And I have an example, I think, of our GeoHose, which allows you connect to our hose and specify bounding boxes. And then in real time, it will pass tweets that match those bounding boxes back to you over that socket. And so this is what our search API, our search page looks like when you actually do a near search. So you can do near San Francisco, and then we sort of pull out all these places, all these tweets that sort of match the near San Francisco query parameter. So like that first one is actually a geotag tweet. Like there's actually a latitude and longitude attached to it. The other ones are either implicitly or explicitly marked as within San Francisco, like either from the user object or from other metrics that we use to find these tweets. And then since we expose it over our API, like this is Tweety, one of our most popular iPhone clients, and they allow you to do geotagging as well on a per tweet basis. So you can see on like Alex's tweet on the right-hand side in the middle, there's a small pinpoint there noting that that tweet has been geotagged. If you bring it up, you can see a map. You can click on that map and get much more specific details, exactly where a tweet's coming from. If you create a new tweet, if you see that pin there, it says you're geotagging it. You can click on that pin and it'll turn off geotagging for that tweet. Our users have liked it. There has been some uptake around it. Of course, if you, like, as we talked about before, because we're exposing the exact location of that pin, some people have opted not to use it because, for example, I think on this tweet, this actually marks where Alex's house is. And a lot of people don't want to be doing that. So Foursquare is all, of course, as well built on top of our API, and as has Gowalla. So if you actually check into a location and decide to tell Twitter on that, when it posts to Twitter, they'll post a latitude and longitude of that place also to your tweet stream. Other people have built stuff. TrendsMap is one of my favorite examples. Like they try to figure out what's trending in different locations of the world. This is a snapshot of the US. And they look at all the tweets coming from different locations and then try to aggregate and pull out keywords that are being mentioned a lot in those streams. Because we're using GeoJSON and GeoRSS, which are pretty standard, Google Maps, for example, will just consume it. So if we point a Twitter timeline to a Google Map, it just plots where the tweets came from without us having to do any other additional integration. And this is the GeoHose I was talking about. So if you were to connect to the hose using that command just from curl, for example, it specifies a bounding box. And you, as a regular user, can get 10 locations that are about 1 degree squared, so about 60 miles by 60 miles. And then in real time, it'll return any tweets that originate from within that bounding box that have been marked with location. So you'll just get a stream of those coming back to you, and you can consume that in any way you want. We also have our own Trends API that we've built on top of all this. So our trends, for example, like if you look at the Twitter front page, those things you see on the bottom are the trending topics that are going through the Twitter ecosystem. So these are the things that people are talking about the most right now, or within the last day or the last week. But we wanted to be able to provide what people are talking about in London or what people are talking about in San Francisco. So we exposed a whole API around getting trending topics for locations. This was written before we launched our own place IDs, so it's based on the Yahoo's Where on Earth IDs for locations. But if you look through our documentation, you can get a list of all the places that we have trending information for, and you can query it, and it'll give you what's those trending topics within the last 24 hours. And then, of course, people have built on top of that. So What the Trend is a site that tries to explain all the Twitter trends, and they consume our location-based API to expose it, and then people can annotate what this trending information is actually about. And this is what we've been working on most recently, and sort of what's been flowing through the talk in general is our sort of GeoPlace API. So no longer are we are still interested for allowing people to geotag, like with exact coordinates. But for privacy reasons and for usability reasons, just to make the interface and experience richer, this is our API, and our mobile client consumes the API to allow you to then, given a latitude and longitude, find all the places Twitter knows about around that latitude and longitude. So for example, if you queried my reverse geocode function right now with the latitude and longitude of the Mandalay Bay, it'll return the Strip in Las Vegas, it'll return Paradise, Nevada, Enterprise, Nevada. It'll return a list of these places with IDs and provide information like what does their bounding box look like, so if you want to put them on a map. If you create the ID, it'll give you exactly what the polygon looks like, so you can also put that on a map and visualize it. It'll tell you what state it's in, what country it's in, try basically give you all the information as developers, give you all the information to display back to the user in a way that they're comfortable with and understand what's going on through the system. And then you can just tag the tweet with the place. You no longer have to tag it with the exact location. So I can tag a tweet with the Strip. I can also tag the tweet with the Strip and the location inside it if I wanted to. So I want to talk about the Strip, but I want to post a picture that I took of somewhere on the Strip. That's also possible through our API. So what it really comes down to for Twitter is that, obviously we're a platform to try to build these location-based services around. We think we have a rich set of APIs that are evolving and growing. But if there are any questions, I'm happy to dive much more in detail on any one of those topics and tell you either the technical ideas behind it or what Twitter is actually implementing around it. Or if not, I will be around and you can just find me in person. Great, thank you very much.